Welcome back. So, in the last class, we discussed the factors affecting the rate of SN2 reactions. There are total 4 factors we discussed. They are the nature of alkyl group, the nature of leaving group, nature of nucleophile, and the nature of the solvent. The first 2 factors we already discussed, that is the nature of alkyl group and leaving group, that is allergen. Now, we are going to discuss about the nucleophile. How the nucleophile will influence the rate of SN2 reaction. Now take this example. Before going into that, there are 3 categories. The nucleophile has been discussed in 3 categories. One is based on the charge. The second is based on electronegativity. And the third is steric hindrance or bulkiness of the nucleophile. First, we see the charge of the nucleophile. You see in the first reaction, so this is the one, the methyl halide, that is methyl chloride, reacting with the OH minus and gives this product. Similarly, the methyl chloride reacting with the water. The first reaction is fast and the second reaction is slow. Why this reaction is slower? You see, this nucleophile is the charged nucleophile. Okay, this is a charged nucleophile. That means this is stronger nucleophile. As you know, the nucleophile means which has the ability to share the electrons. That means this one, whatever the lone pair, the excess of electron in the charged nucleophile is very easy to donate. Okay. As a result, this reaction will go faster. So that's the reason the charged nucleophile or electron-rich nucleophiles influence the rate of SN2 reaction. That reaction will go faster. But you see this one, the water, this is a weak or neutral nucleophile. Okay. There are no charges. So that's why this will not ready to donate or share its electron. That's why these reactions are very slow. Okay. So that means the charge of the nucleophile will influence the rate of reaction. Next category is electronegativity. You know this electronegativity means it has the ability to pull the electrons to their side. You see, this is the NH2 nucleophile and this is OH minus nucleophile. Both are electron rich. Then why this NH2 minus nucleophile is going faster and the OH minus nucleophile is going slower? The reason is, as we discussed, the nucleophile has the ability to share the electrons. If the electron, whatever this electron rich, if the negative charge is stayed on the highly electronegative atom, you see, the nitrogen is less electronegative than oxygen. Nitrogen is less electronegative, okay, than oxygen. So if that it is more electronegativity means it will withdraw their electrons towards their side. So the negative charge in the most electronegative atom is not ready to share its electron. But if the negative charge in the least electronegative atom or more electropositive, can't either way. So the NH2 minus will go fast because this negative charge is on the least electronegative atom. Okay, that is ready to share its electron, but this one oxygen is not ready to share its electron because this oxygen is highly electronegative than nitrogen. That's why this will get fluid. Okay, so electronegativity plays an important role on the electron rich nucleophiles. Here both are electron rich, NH2 minus and O minus, OH minus. Next is steric hindrance. You see here, in this case also both are electron rich nucleophile. Excess charges is there, CH3 O minus, and this is methoxide, and this is tertiary butoxide. Both are electron rich nucleophile, but this one goes faster, methoxy, and this one goes slower, tertiary butoxy. The reason is this is a bulkier nucleophile. So the bulkier always reduce the rate of SN2 reaction. Okay. So in summary, so that strong nucleophile will faster the reaction. The electron rich, that is in the least electronegative atom, that will facilitate the SN2 reaction. The bulkier nucleophile will reduce the rate of reaction, or electron rich nucleophile but it is not bulkier, then it will faster the reaction. Okay, so these are the summary of the effect of nucleophile. The next is the effect of solvent. First of all, we should know what is the purpose of the solvent. Solvent is a medium to form a homogeneous condition. Okay, homogeneous condition to facilitate the reaction. Okay, to facilitate the reaction. As a result, the collision will occur very effectively. That's why we need a solvent. Okay, this is the purpose of solvent. Now, the solvents are two types. One is polar and another is non-polar. Now, which solvent we can use, either polar or non-polar? Now, there is a quote, like dissolves like. That means in the reaction alkyl halide, the nucleophile all are a charged species. Okay, so that means these substrates can easily dissolve in the polar solvent. Okay, so that's why we should choose the polar solvent for this SN2 reaction. Now, again there is one typical situation, but the polar solvent is further divided into two categories. One is polar protic and polar aprotic. Protic means which has the solvent which has the ability to donate the proton. Polar aprotic means it does not have the proton to donate, but both are polar in nature. So we know that polar solvent we should use, but which one we should choose, whether polar protic or polar aprotic? Which solvent we should choose for the SN2 reaction? We should choose always polar aprotic solvent. Why not protic solvent? Suppose if we choose polar protic solvent, it is having proton. You see, the nucleophile, the polar protic solvents can solvate the nucleophile. As a result, the strength will get reduced and it have the endurance to attack this partially positive charge carbon. That's why we should not choose the polar protic solvent. Okay, but so why we should choose polar aprotic solvent. Polar aprotic solvent examples are like this acetone, DMF, DMSO, like that. Okay, so these are protic solvents examples with alcohols, water. These are like that. Okay, examples. Now, if you choose polar aprotic solvent, there won't be no hydrogen bonding such thing we observed in the polar protic solvent. At the same time, whatever that the partial negative charge of the solvent, you see in the acetone, the partial negative charge of the acetone, it solve weight the electrophilic carbon and facilitate the SN2 reaction. That's why we should choose for SN2 reaction polar aprotic solvent. Okay, so that's all. Hope you understand this. All factors affecting the rate of reaction. Next class we discuss the SN1 reaction. See you.